Hello everyone and welcome to Space Studios and to the first episode of exploring our solar system. Today we are going to explore the sun. So without wasting our time, let's get started. So sun is a hot glowing bulb of hydrogen and helium in the space and about 4.5 billion years old. Sun is the largest object in our solar system and its gravity holds the whole solar system together. Its mass is about 1.989 into 10 raised to power 30 kg and the sun could fill up 1 million earth in its volume. The sun is a yellow dwarf and it doesn't have the same temperature all around. It's about 15 million degrees Celsius at core and about 5500 degree at surface, and its atmosphere is about 1 million degrees Celsius, which means that its atmosphere is hotter than its surface. Well, that's amazing, but we will discuss that later in the upcoming session of this video. Now let's talk about the building block of sun and answer the question that what is sun made up of? The sun is a big ball of plasma mainly consists of hydrogen and helium. At sun's core, the gravity creates tremendous amount of temperature and pressure which leads to the fusion of hydrogen into helium, and the process is called as nuclear fusion. With the use of this process, the sun is generating its energy from billions of years. Now it's time to discuss the structure of sun. The sun is basically consists of three main regions, namely the sun's interior, the surface or photosphere, and the solar atmosphere. So now let's discuss the sun's interior. It is basically consists of the core, the radioactive zone and the convective zone. So as you can see in the diagram, the core is at the center and the hottest region, and it is the place where nuclear fusion reaction takes place. The next zone is radioactive zone. In this zone, the energy is carried outward and carried by photons as thermal radiation. And the third zone, the convection zone. In this zone, the heat moves upward like bubbles, and it is similar to bubbles formed when we boil the water. Now, let's talk about the next zone or the next sphere, that is photosphere or the surface. The boundary between the sun's interior and the sun's atmosphere is called photosphere. It is a visible surface of sun but mainly composed of gas. So, if you somehow reach there, you can't stand on it. Some of you might be thinking that sun doesn't have an atmosphere, but that's wrong. The sun has an atmosphere and is basically divided into two regions. First, the lower region is called chromosphere, and we hardly can see it from our naked eyes, as it is less denser than photosphere. But you can see this region when there is a full ellipse. It appears as red. Now let's talk about the most interesting region of sun, the upper region of solar atmosphere, the corona. It is the biggest and the least dense region of solar atmosphere and mainly composed of plasma escaping the sun. An interesting fact here is that the corona is much more hotter than the photosphere, and it is due to the fact that magnetized waves of plasma could carry huge amount of energy along the sun's magnetic field from its interior to the corona. The energy bypasses the photosphere before exploding with the heat in the sun's upper atmosphere. Now let's talk about the birth of sun. So how was the sun born? It all started 4.5 billion years ago. In the Orion arm of Milky Way galaxy, there was a cloud of dust and gas called as solar nebula, mainly composed of hydrogen and helium and remnants from the violet death of stars. 4.5 billion years ago, waves of energy passing through space pressed the particles of solar nebula close together and caused them to collide onto themselves and make them spin. The spin caused the cloud to flatten like a disk. In the center, the material came together to form a protostar. The protostar was a ball of hydrogen and helium but without fusion. Over 10 million years, the temperature and pressure of protostars started to increase, jump starting the fusion of hydrogen and making the sun we see today. And now let's discuss the ending of sun. But before that, if you enjoy the video, like it and subscribe the channel for more. So, how the sun ended? In about 5 billion years, the sun will run out of fuel, means hydrogen. With no hydrogen left to fuse, the gravitational force will compress the core and allowing the rest of the sun to expand till the orbit of Mars. And that's when the sun will become a red giant and it will remain for about a billion years. Then hydrogen in the outer core will deplete, leaving helium. Helium will then fuse into other heavier elements like oxygen and carbon. When once all the helium is depleted, the gravity will take over, shrinking the sun and making it a white dwarf. So that's how our sun is going to end. And this video is not over yet. I have an interesting fact for you. And the fact is that the sun is about 26,000 light years away from the center of our Milky Way galaxy and is situated in the Orion Arm. Every 230 million years, the sun and its solar system makes one orbit around the center of our Milky Way galaxy. This means that the average velocity of sun is 4,050,000 miles per hour. That is too much, and we even can't feel this. We are just moving with this velocity, but we can even feel this velocity. And this is amazing, So this is it for today, guys, and hope you guys enjoyed it and like the video and subscribe to the channel, and meet you in the next episode of exploring our solar system. Till then, goodbye and thank you.